Okay, recall from section 4.1 the graph of the exponential function f of x equal 2 to the x. This is an exponential function because 2, the base, is constant and the exponent x is a variable. So I'm going to go ahead and graph this like we did last time in the other video, and I'm going to pick 0. That, of course, gives us 1 because any base raised to the power of 0 is always going to be 1. Now, if I go in the positive direction, if I take 2 and raise it to the power of 1, in other words, if x is 1, I get 2. If x is 2, the exponent, I get 2 squared, that's 4. Now going to the negative direction, minus 1, that negative just means I take the reciprocal, so it's going to be 1/2. And if it's negative 2, it'll be 1/4. So plotting these points, you can recall the shape of the exponential function is like this. Now, one thing you'll notice about this function, it is a one-to-one function. Because it passes the vertical line test, in other words, every vertical line crosses only once, we know it's a function. And because it passes the horizontal line test, every horizontal line only crosses once, it also is one-to-one. And that means it has a function inverse. So what is that function inverse? Well, graphically, if we draw the line y equal x, and then reflect the graph, this graph of y equals 2x to the x power, we are going to get the inverse of y equals 2 to the x. And this, remember, is 0, 1, so 1, 0. We switch x and y. Remember, to find the inverses, we switch x and y. Here is 1, 2, so we want 2, 1 as a point. This point is 2, 4, so we want 4 and then 2. And here we have negative 1, 1/2, so it's going to be 1/2, negative 1, negative 2, 1/4, so it's going to be negative 1, or 1/4, negative 2, and we get a graph like this. Now, this is a function. It passes the vertical line test, and it also passes the horizontal line test, and it is the inverse of y equals 2x. Well, recall the equation of this line is x equal 2 to the y. And that's because when you're looking for the inverse, you're switching x and y. So if I switch x and y in this equation right here, I get x equals 2 to the y. Well, this is the equation for this line, but this is not in function notation. So in order to have a function notation, we have to create a name for this. So that's all this is. F of x equals log base 2 of x. This is the name of the function that is described by this equation. And in exponential form, the equation is x equals 2 to the y. It's not an exponential function, it's a logarithmic function, but this is the way we describe it. The independent variable is x, and the dependent variable y is the exponent, as opposed to this function here, where the independent variable is the exponent. So this is a logarithmic function, and this is the definition, the exponential form. And in logarithmic form, we have y equals log base 2 of x. And this log base 2 is simply a notation for the function. It's the name of the function. Log for logarithmic and 2 for the base.